Hi everybody, and welcome to another episode of Amiga Game Development by me, Geezer. We're currently up to episode number 4, and I hope you've had a great week and haven't found episodes 1, 2 and 3 too difficult to get through. This week we're going to be looking at assets and resources and getting into something specific on the Amiga. So we are actually going to be touching the Amiga and more importantly actually loading some files into memory and unpacking them. So as I normally do, I'll run a recap of what we did in episode 3 and just go through the normal structure that I've been doing, and hopefully you'll pick it up and start doing a fair bit of coding. So I've got the most important thing, which is beer in hand, and I'll run through this episode completely uncut. I just do these. I don't edit anything. I just tell it like it is. So if I make some mistakes, then I make them. I'm not perfect by any stretch of the imagination. So yeah, let me know what you think in the comments when I upload the video. And likewise, just to point you in the right direction, I have the AmigaGameDev.com website, which you can go and look at, which has all the episodes and all the files that I'm going to be talking about here. And you can post questions, comments, things like that. I've also got the Facebook Amiga Game Dev page, which you can go on to and ask me questions there. I tend to hang around there. And I also hang around on Discord as well, and that's the link for the Discord channel that I have, where got quite a decent community of people actually hanging around there. Now, there's about 40 people when I last checked, and yeah, I'm sure if you go on there and ask a question, you'll find no shortage of people happy to discuss things with you and answer your questions. So on with this week's episode then, and assets and resources. So topics covered in this one, episode number 3 recap: accessing the Amiga libraries, very important, and we're going to be looking at a bit more in depth on the Amiga memory types. We're going to be looking at allocating some memory, loading files using the Pro Packer. It's the Rob Northern Computing Pro Packer. We're going to be looking at what a packed file actually looks like. And we're going to be also needing to make a couple of little changes to the VASM environment that we've set up, in particular because the project that we're going to be doing is going to be getting bigger. We're going to need to learn a couple of techniques, in particular modular coding, as I call it, which I'll come on to, and we're going to be needing to use some of the operating system libraries, which is pretty important really. I'll show you how to include those. And then what we're going to do is we're going to put everything together, and we're going to create ourselves a little loader, which you can use to load files into the Amiga memory. Okay. So a quick recap of episode number 3. What we talked about was loops. We discussed gave an example of a typical for loop and how you might do that in assembler using a counter, and you using the compare instruction to see if it's reached a particular value. And we also looked at more efficiently what could be deemed as a while loop effectively in assembler, and that was using the decrement branch if false instruction, which is a bit more efficient because there's a few less instructions to actually deal with. What we also talked about was bit shifting, which I did say very important. You'll find you start to use bit shifting a lot when you come to coding. It really does. You really do need to know what it's about. So if you've got any kind of if anything doesn't quite fit in with that, what I suggest you do is have a look back at that particular episode, and if there's any questions, like I say, you know where to look, you know where to find me if you're unsure about the bit shifting stuff. We looked at the Amiga memory overview, so the types of RAM that we have in different stock machines, namely the chip RAM on a 500, on a 600 and a 1200. We are going to cover that a little bit more in one of the slides in this episode. We looked at the load effective address instruction, or I call it LEA, and we effectively took a pointer to an address and we put that in one of the address registers that is part of the CPU. So typically the address registers we covered, there's A0 through to A7. We loaded an address into A0, I believe it was. What we also did as well is we looked at the more capabilities on the move instruction, not just about moving stuff into a data register or an address register. We looked at actually what's called dereferencing memory, so we were able to kind of manipulate the contents of memory, which led to things like being able to copy a block of RAM around in memory, which in effect, when you're making a game, you tend to manipulate lots of the screen and things like that, and basically all it is just moving memory around in different regions. That's effectively all it is. And what we did is we took a simple sprite handler from or a sprite handler example, and we applied that to some enemies from the classic game R-Type. We looked at how as the player kind of started off in the game and moved through the game. We looked at how the sprites in the game might be manipulated using a sprite handler. So when sprites were active on the screen, there was a sprite type put in to one of the slots, and when the enemy was killed by the player, the sprite was actually deallocated from the game through the handler. So that was a very, very simple example of how a sprite handler might work. Okay. So here we go, accessing Amiga libraries. Now, when you do some programming on the Amiga, and we've just talked about it there, about allocating memory, you typically do that through access to the Amiga library. So the operating system libraries that are available, you call these functions that are available from the operating system. And there's two libraries in particular that I really wanted to cover. The first is the exec library, which is used to typically handle things like allocating memory, freeing up memory, creating new processes or creating new tasks, and other things like that. And the other library which we're interested in is the DOS library, which is the disk operating system library. And now the functions that we typically want to look at for this one is those that are manipulating files. So we'll be looking at open file, read file, close file, and some other functions as well, notably seek. So we want to be seeking into a file and seeking back and reading some bytes and things like that. Now, in order to open a library, you have to, or if you want to access, say, the DOS library, what you need to do is you need to call the open library and close library functions. Now, what happens is when the Amiga boots up, the exec library is available straight away to be used, because if you think about it, this library has to be available so that the Amiga can do certain things like allocate RAM to start loading data from a disk, for example. It can't have every single library open straight away. Number one, that would take too much time, and another thing, it would just suck up too much memory of the Amiga. So they kind of made these libraries that if you wanted to use them, you just call the open library. Now, open library is part of the exec library, and as is close library. So what we want to do is that if we want to call the exec library, and that is available on boot up, there's a bit of a difference in how that is actually accessed. The exec library can be got at by simply reading memory address hex 4, and I'm going to show you what I mean by that in the next couple of slides. So this is, if you're a C programmer or you're familiar with C or that higher level language, this is kind of what the open library function will look like. What you do is you call open library, which is the Amiga DOS function, the Amiga library function, and you give it a pointer to the library that you want to open. In this case, we're talking about the DOS library. You would have a string that says DOS.library, and it would be null terminated with a 0. And you also supply a library version as well in D0. So that typically are normally set to just null, just 0. And what you get back from when you call this, if you do it properly, you'll get back a pointer to the library that you've wanted to be opened. So in this case, if we were calling dos.library and we wanted to access the DOS library, we would get a pointer to where the dos.library functions are, which we can then use to call those functions that's within that library, and so forth and so forth. Now, to do this in assembler, this is what it would look like. Now, if you remember, the open library function, as I said, is part of the exec library. Now, to access the exec library, you just read the 32-bit address or the long word of memory region $4 or hex 4. Typically what you do is you put that into the address register number 6, here 6, and what we do is we say, right, layer load effective address with the dos.library into ear 1, and we clear the library version in D0 as we said here, and we make the call open library brackets here 6, and that makes the call here. And if we get back a 0, if D0 is 0, then we've actually encountered an error. So this branch to a local label here, branch if equal dot error, that would have to be a error handling routine that would go off and do something else and say, oh, problem with opening this particular library. But if it doesn't, then what we get back is, like I say, we get back to this library base pointer of the DOS library, which we can then save and use later on to access functions within the DOS library. So that's how you do that. And string DOS library, as we said, is just a pointer to a string, dos.library, null terminated. Pretty straightforward. Now I did touch on this, and I says I'd touch on it a little bit more because it's pretty important, this one. When you're allocating memory, just to quickly recap, these are the memory ranges that were typically given by, I guess they were given by Commodore really, or Amiga Incorporated. And if you had an OCS chipset or an A500 and you bought one, you would get a 512k of chip RAM. If you had an ECS machine, which was an A600, you'd get 512k of chip RAM as well, so that would give you 1 meg. And if you bought an A1200 machine, you'd get another 1 meg. And if you wanted to allocate memory of chip RAM, you would typically be given a range of memory in the operating system from 0 through to whatever these ranges are, whatever was available in the machine at that time. Now you do have other types of memory, and just want to touch on this one here, the internal expansion memory. And somebody corrected me and says this is actually slow RAM, and it is. It was typically the trapdoor memory that you will put in a A500, if I recall. I know I had an expansion RAM. I can't remember if it was 512k or 1 meg, but basically I was able to put a little memory expansion in this expansion slot under the Amiga, and that gave me some fake fast RAM. When we say it's fake fast RAM, it's not real fast RAM. It is effectively a bit more chip RAM, to my knowledge, because it operates as fast as chip RAM, which is the slowest type. Now, if you had real fast RAM, so I guess that's actual memory chips slotted inside of the machine, the RAM you'd get allocated will be in this region here, 200,000 to 9 FFFFF. And these are the ranges here we're going to be coming on to a bit later on. But the main point of this is that when you request memory from the operating system, you get the option of these types. There are other types, but these are the 3 main types. You can say, right, I want some fast memory by calling this constant here, or you want some chip RAM, or you want any RAM. Now, the any RAM will say to the operating system, just give me whatever's available. But what it will do is, if there's some fast RAM available, it will give you that. So you've got to be careful. You've got to be kind of careful and understand what that's going to do. Another point is that, remember what I said about these being stock machines with chip RAM? If your program requests fast RAM and it runs on one of these stock machines, those stock machines don't have any fast RAM, so your program would fail. So what I tend to do is, if I want some fast RAM, I would typically say, right, give me memfany, And if I want some chip RAM, which is what you do need to do as well, I would say, right, allocate some chip RAM. It's very rare that I ever say I just want some fast RAM. Very rare at all. So allocating memory, here's how you would do it, which I'll just walk you through. Here you've got the mem size that you need to put in the D0 register. So imagine if you wanted 4K of RAM, you will put in 4096 into D0, and D1 will be the type of memory which I've just talked about, memf fast, memf chip, or memf any. And you will put the exec lib base, which is in hex 4 of the Amiga's RAM, into the A6 register, and you will call allocmem using JSR brackets A6. And hopefully it'll give you a pointer back, which is a pointer directly to where your RAM segment is that the operating systems gave you. And great, you can then go ahead and use that. And that's what that looks like there in assembler. So mem size equals 4K, that's what you want to allocate. And reading $4 into A6, and then we set our mem size in D0, then we say memf any in D1. JSR LVO alloc mem. I do apologise, there should be an A6 in there, so I will correct the slides before I upload them. And then we check to see if there was an error. If there was no error, we store our pointer to where our RAM was, and we can take that for later use. So yeah, that's typically how you do that. Okay, reading files. So we've allocated our RAM. Now we want to go and maybe read some files into that RAM, and these are the steps that you would typically do. So the top one we've already just touched on. So this is allocating memory, I should say. And then what we want to do once we've done the allocate of memory, we want to say, right, we want to open the DOS library, which we've just touched on as well. Set D0 to 0, A1 points to DOS.library, put the exec base in A6, call open library, excuse me. And then what happens here, when you call, sorry, I do apologize, this is the open file. So when you get the open library, you'll get the DOS library base in D0. Okay, so now we want to read a file. So what we typically do is we'll say, right, we put a pointer to the file name that we want to open. So that might be, I don't know, DH1 or DFO filename.txt or something like that. And we put that pointer in D1, and we give it a mode to open as well. So the mode might be something along the lines of, well, we just want read access to a file, or we want write access to a file, or read and write access to a file. And again, what we'll do is we'll take the DOSLib base, which we got from here, and put that into A6, and then we'll call the function open file. Now what open file will actually do is it will return back to the program. It'll return what's called a file handle, and it returns a file handle because at this point in time it doesn't know what you actually want to do with the file. For all it knows, you might want to read the file, write the file, you might want to close the file, you might want to seek into the file. There's a whole host of reasons why it gives you a file handle, because it just doesn't know what you want to do. But it does. It gives you a file handle, and what you can then do, whenever you want to reference that file, you reference it via its file handle that it's given back to you. So in this one here, we say D1 equals file handle, which we just got back. We say D2 equals the buffer. Now the buffer is the memory allocation that you got from allocating the memory. So the value of D0 that was pointed in here, which we saved away, we now put into D2. And in D3, we say, right, the length of the file. Now, in here, we might just want to read a part of the file. And we only might maybe want to just read, maybe 20, 30 bytes, just to read what maybe the file header looks like. Other times, we might want to just read the contents of the entire file. But again, we're using the DOS library to read a file. So in A6 goes the DOS library base, and we call the function read file. And in D0, we get back the number of bytes read. Now, if you're supplying a length in D3, you probably want to error check to see that, okay, we wanted to read imagine it was 4K of the file, right, put 4K in there. Did we read actually 4K? Yes or no? Great. And lastly, what we want to do is that given that we've got the file open, we will typically want to then close the file. So what we'll do is we'll put the file handle in D1, as we've done with all the rest, and DOS label in A6 and call close file. And that is that. That tastes good. So now I'm going to come on to Pro Packer. So this is Rob Northern Computing's Pro Packer, which was a common packer that was used, I guess, around the heady days of the Amiga's prime. But you know, it's available now. I think it's on AmiNet, but we can use it. We can use it fair and square here, and it's really useful, really easy to use. And I'm going to show you how to use it. So typically, the packer is that the only way I was able to squeeze as much data on the Rygar disk was through the use of a packer, and the packer that I used typically was Pro Packer. And I used tried quite a few other packers, and they were good to a varying degree. Some were more difficult to use than others. What I found was a best all-rounder was the Rob Northern Computing Pro Packer. So I'm going to show you how to use this now. So what we have is we've actually already got this set up. So if you boot the, sorry, my TV has just come on. If we start up our Monam session on the debug virtual machine, we can press Ctrl and C and we'll quit out of that. And on that machine, if you go into System and then I believe it is, I think it's just there. We'll find out in a second. But what you want to do is run up a shell, an Amiga shell, or a Workbench shell, I should say. And then what we're going to do is we're going to say, right, we're going to go into dh1:propack, and then we can call pp.ami.exe, and we will see all of the options that are available with the packer that are here. And we can see that we can call pp and then a command, file type, and some other things here. So we're going to be using the pack command, which is p, and we want to pack data, which is just a data file, because what we have is we have a typical Deluxe Paint IFF file that we're going to pack. And there are other options as well, such as unpacking, but we're not going to really touch on them. We're just interested in these ones here. Now, what you're going to need, and I'll provide the links to where this source code is, you're going to want the unpacker source code to actually do this. So I'll provide the links on the amigagamedev.com. And unpack.asm, you want to put in development Amiga Game Dev, and there it's there where I've put it, just there. And I've created a little IFF file which you can download, and you'll want to be putting that in development Amiga Game Dev machines A1200 debug DH1 Pro Pack, because that is the file that we are going to pack. So what we're going to do is, this is just an example of what it looks like, or what you should see. We've CD'd into Pro Pack here, ppemi pack data, and I've got safk emblem.iff here, and we can see that what it's done is it's packed, the size of the file is 53k, and it's packed it down to 17k, and we've got a ratio of 67%, which is fantastic. And you can see the two files then exist there. Yeah, I'm just highlighting those there. Okay, and that's where they'll effectively be. So what I'm going to do before I go on to looking at the header, I'm going to actually just run through that and run through the packing of that particular file. So over to the virtual machine. Well, this is actually where we left off. So the first thing I'm going to do is just check what files we have. And we're going to go into our folders that we created for the machine, C drive, and then development, machines, debug, DH1. So we've got ProPack already there, and we don't currently have the images, so I will just, what I'll do, which I already have, I believe, just copy this image in. So I'm just going to copy this uncompressed IFF file into there, into the ProPack directory. Okay. And what I'm also going to do is I'm just going to make sure that I've got the unpack source code as well, unpack.asm. So I haven't got that at the minute, and I'm going to need it. So I'll actually provide the link to that as well. But I'm going to be needing that at some point. Okay, so what we're going to do is we're just going to take it from where we left off and just get into Amiga Workbench. Once we're here, we can just press Control and C, and then yes to quit, and it'll quit us back to Workbench. So we've got the standard tools that we have available, and then just click on System, and then System again, and then we want a shell. So here's a shell. Okay, so we want to go on to type in DH1, and then we want the CD and the ProPack, and we can type in list. I believe I'm not that great with Workbench, to be fair. Now if I just type in here ppami.exe, I should see, yeah, that's the typical, that's what I would call in the Linux world the man page, or the help page, I guess. There you can see, call the command pack data. So what we're going to do is just going to ppmi.exe pack data, and then our file that we want to pack is safkemblem.iff, and off it will go packing. And with a bit of luck, it shouldn't take that long, but the last time I did it, it took absolutely ages to do for some reason. So if it starts doing that again, I've got a snapshot on the virtual machine, which I can just bring up. If it, see how long this is going to take. Yep, it's going to take too long. So what I'm going to do is I'm just going to, like I say, I've got another snapshot, which I'm just going to say, because it has the completed source code on anyway of what we're going to cover in the next few slides. So I'm just going to bring that up again. DH1, CD ProPack, and I'm just going to do a list, and hopefully there you go. So there's our safkemblem.rnc. Now notice how it's took the actual file name, but it's renamed it to .rnc. So that is the packed file name that we have. Now what we're going to do is we're going to take that file and we're going to have a look at it and see what it looks like in Monam. Okay, so let's just do that right now. So if I just simply come back here, and if I go into dev, no, quickest way is to simply just reboot the machine. We should get there. So just loaded up Monam there. Now if I press B, it allows me to find it, lets me load a file. So if I type in dh1 ProPack / safkemblem.rnc, And with a bit of luck, there you go. It has loaded that. So what I'm going to do, just while that's ready, I'm just going to go back to the slides and show you what this actually looks like. So Shift F5. So over on this side, this is the packed file header. Okay, so we've loaded the file and we're pointing right at the top of the file that's loaded. And you'll notice that it has some bytes here and it says RNC. So that's the string header. And then we've got a version which is 01 or 02. Now the Pro Packer allows you to work in two modes. I think one mode is for compression, so there'll be greater compression, and mode 2 is for greater unpack speed. Now we're more bothered at the minute about greater compression, so that's why that's at version 1, and that's the default that we've got selected. So that's why that says that. What we've also got is we've got the original unpacked size of the file. So remember that was 56K, which is here. And then we've got the packed file of this packed file size as well. So that's the current size of the file in its packed form. So what we're going to do is we're going to take this packed file and we're going to read these first kind of 16 to 20 bytes from the file. Okay. And then we're going to read these bytes here, the unpacked file size, right? And what we're also going to do is we're going to check using our bit shifting methods and compares instructions that this is in fact actually a Rob Northern Computing packed file, and just check that little header there. So we're going to check the little header and then we're going to read the unpacked file size, and then what we're going to do with that is we're going to say, right, we know that the unpacked file size of this file is 56K. We're going to say, right, allocate 56K of RAM and then unpack the whole file into that RAM segment that we've just allocated. So it's going to read a packed file and then unpack it, which is exactly what we want. So it's going to put it all together. We're going to be opening the DOS library. We're going to be reading the packed file header, that first 20 bytes or so. We're going to be allocating the RAM based on that header, so the unpacked size. I'm going to seek back to the start of the file, which I'm going to come on to, because what happens is when you start reading bytes from a file, there's like an internal counter which says, right, I'm going to read 20 bytes, and it's then set at a point. So what we need to do typically is read back from the start of the file, and then what we're going to do, read the whole file in, and then we're going to unpack the file as well. And then what we're going to do is we're going to return a custom handle for our loaded assets to say, look, this is where the file is being loaded and unpacked to, and if you want to use it, here's where you can find it. And that's basically it. So let's have a look. Now before we do that, I do apologize, we need to set up some extra things in the toolchain, and this is what they are. Okay, so we need to, and I'll bring these up in the screen in the screenshots on the virtual machine. Sorry, what we typically need to do is we need to copy this include folder here and put it into this folder, the development Amiga game dev include. That's where that needs to go, and we need to, in the build command line on VASM, we need to include that. So I'm just going to show you that right now so that you can make sure that you can follow along. So on the virtual machine, if we just drop that to one side, we're just going to look at plugins, npp exec, execute, and I do apologize, there's no way to kind of make this any bigger in this here. I will try though. Let's see if I can make that bigger. Style configurator, let's try making this 28. Ooh. It's quite big, isn't it? npp exec. No, it's still the same size. But what I've done here, and I'll put this on the documentation, is that we've added on this command line here, -I C:/development/Amiga game dev/include, and we've just added that in there. And that tells Vasm to include and look for particular libraries which we're going to be coming on to. So I'll just set the font back to maybe make it a little bit bigger. Maybe it's 22. That's a bit too big. 18. Yeah, it looks better. Okay, I'm just going to show you what that include looks like and what the unpack looks like as well. So C:, and if we go into development, and we've got Amiga game dev, you'll see we've got an include file here, include folder, I do apologize, and in there we have all of these libraries and stuff. That is what you want to put in there. It's that straightforward. And we've got the unpack.asm source code as well. Now what you want to do is, I've got the completed source code here, which I'm just going to run through with you and tell you exactly what it does. I will upload the source code, but what I really wanted to do was show you about kind of not putting all of your source code all in one file. That's a bad idea. As your project grows, you kind of want to split your project out into different files, and otherwise it just becomes a huge mess, and you spend most of your time just kind of looking for those functions that you've written, and it just becomes you'll just get demotivated, and that'll be it. You'll just fail to move forward. So what I'm going to do is just show you a couple of techniques that I use with Notepad++. First thing I do is I'll do file and then open folder as workspace, and when I do that I can go into C and find our folder, say Amiga game dev. So that's what I've chosen there. I'm just going to say OK there. Now you'll see what's happened. Notepad++ on the left hand side here has opened the source files available that I can now just click onto. So if I click unpack, you'll see this is the unpack source code, which I can then peruse at my leisure. And we've got some other source files here as well, which we're going to go through because this is the actual point of the episode. We've got another include here, and we've got some assembler here because it ends in .asm, and that is really that. So we're going to actually just compile this up and see what it does, and you'll notice at the top here we've got the different tabs that we can just click on. So we've got main, unpack, loaded.i and loaded.asm. We're not really bothered about the unpack.asm, it just does a job for us. So we're quite happy with that. Now, when I talked about that modular coding, what we have to do is we have to declare which other assembler files and which other included files we want in our main file. And we do that by using this include directive here. But because we're using the exec library and we're using the DOS library, we also have to include those as well. So what we need to do is we need to just declare that we want to bring in these parts of exec that we're going to reference in our code, and we need to bring in the DOS library includes as well, which we're going to reference in our code, and you'll see that later on. Now what we have in here is these are includes here that we've actually built ourselves. So we've built some loader constants because this effectively is just a loader. Its purpose is to load files, and we've got a loader.asm, and we've got an unpack.asm which just neatly does all the unpacking for us. We rarely ever need to go in there, so we just include it so that it's out of the way and we don't need to be bothered with it. So what we're going to do is we're going to run down all of the things that I'd mentioned here. We're going to run down these and just trace them with Monam and just see if we can follow along, and hopefully it will come into place. And I'll show the source code as I'm doing it. So I'm just going to move this across to here, and I'm just going to talk through it. Okay, So perhaps if we make things a bit bigger, we can just do that. So as I mentioned, what we've got is we've just got a declared address here of exec base, which equals 4, because we're going to need that. And what we've got here is we've just got a branch which jumps to our start, and we'll see that in Monam in a second. Now, as I mentioned, the first thing that needs to happen is that we're going to open the DOS library, and that is the code that we've used previously. I've put the functions in there. So we just load exec base into EA6, we load DOS name, which is the DOS library, into EA1 using layer. Version, I believe that means any version, or the default version. We make the call to open library, and we store the DOS library base into DOS base. The next thing that we do is we've built a loader function. Okay, we've built our own loader function which we're going to call, and the loader function looks like this. So we've got, I should say AGD, Amiga Game Development, load and unpack asset, and then we've got a pointer to the file name and the memory type that we want to allocate for that file. That's where we're going to, so that's the file name to load, which is in our case is going to be safk emblem.rnc, and mem type is going to be memfne or memffast or memfchip, and in this case we're setting it to memfchip. Okay, so it's going to make this call to AGD load and unpack asset. Now you'll see that in this main file it's not actually here, so where I've put that in loader.asm, and as you can see that's where it is in here, and at the top I've put what the actual function looks like. So what we can do, you will see that the things that I talked about, opening the file for reading, because we already have the DOS library open, we're going to load the header of the file. This is the number of bytes to load. We're going to check the header of the file. Okay, we're going to make sure it says RNC at the start of it, and then we're going to load, then we're going to get, if that's okay, we're going to say, right, we want the size of memory to allocate. That's what this part here is doing, and we're going to call allocmem, and we're going to then say, right, okay, we want to read the file again, or we want to seek back to the start of the file, I should say, colon LVO seek, and then we want to read the entire contents of the file again, because the file size is set to FFF, which is just basically read the entire contents of the file. And then we're going to close it, and then what we're going to do, we're going to say, right, once the file's loaded, unpack it, and then return where the file was loaded back to the function. So let's give that a shot. Now I'll have to explain a couple of other things as well. In particular, this new instruction, which is move m, which is move multiple. And what it does is that, as you can imagine, when you call some of these functions here using BSR or JSR, the registers get effectively changed, and sometimes that's not a good idea. So in order for to keep them intact, when a function gets called, you can save the registers on the stack pointer, and that's what these move multiples do. It's saying move multiple, long words, save registers D1 through to D7 and A0 to A1 onto the stack pointer here. That's the first instruction that gets executed. And then when the function exits, just before the return from subroutine, it says, right, move multiple from the stack pointer, dereferenced, move the registers back onto D1 to D7 and A0 to A1. So it just puts everything back to where it was. And we'll see an example of what's going on with that when we do it. So let's press Shift F10 and see if we can get things up and running. And what I'm going to do is just close that one. I'm going to do Shift F12. Okay. So here's our program running. So what we're going to do, we'll follow along in the Notepad++ session, which I should be able to get here, and see if we can follow along as best as we can. Oh, I've done that again. Apologise. So you see we've got a branch start here, so that's gonna, this branch is just going to skip all over this code, jump to start. So we are now pointing at this point here. Open the DOS library. So we're going to move the contents of address 4. Now what it's moved is, this is pointing to the exec library. And we're going to load DOS name into EA1. And as you can see, DOS.library is at the top there in the EA1 register. 0 into D0 for any version. And we're going to make the call to open library. And that's what it has done. And as you can see, it's returned D0 with an address which is the function start, or the function pointers of the DOS library. So we'll save that for later use. And now what we can do is we say, right, let's load the file name that we point to the file name that we want to load. And if we take a look at A0, we'll see that A0 is pointing to dh1:safkemblem.rnc, and we're just going to set these. So you can see that we're actually down here now. Now internally you will see that we've got the file name here, and then we've got the 0, and then the MF chip has actually been, when it's been compiled, it's been set to 2 because the constant of that is 2. So in the Amiga OS libraries, memf chip actually has actually got a number of 2, and that's how it gets translated here. And now what we're going to do a call to AGD load and unpack. So when we go into loader, we're going to be pointing into this here. So if I just press Ctrl Y, and then here's this move multiple onto the stack, and it's going to save all the registers, and that's what it's done. So the first thing it's going to do is, because we've supplied on D1 the memory type, it doesn't need the memory type to allocate straight away. It needs that probably as one of the last steps, because the function's got a fair bit to do before it actually gets to allocating the memory. It's got to read the file, it's got to read the header of the file, sorry, and then it's got to read the unpacked size, and then before it gets to say, right, I need to allocate some memory. So what I'm doing is I'm just going to save that register D1, which is the type of memory, and I'm just going to put it into D5. And I'm going to take A0, which is the pointer to the file name, which we're going to use later on, which we're going to need to have in D1, which is what the open function requires. So it needs a pointer to the file name in D1. So what we're going to do is we're just going to say, right, okay, and we're going to put the mode, which this kind of means just read file, I believe it is. So we just do that, and we're putting the DOS base functions library in A6, and then we're going to do a call to open file. So this is where we are here, JSR open file. And what we should get back in D0 is a handle. And that's what we do get back. We've got a handle here. That's what that is. So we're going to just check to see if we've got a handle. Yes, we did. And we're going to store that in D4. Now what I've got here, because we've managed to open the file, we are now going to actually just read the first 20 bytes or so into a small piece of memory. Now that small piece of memory is this bit here, this AMG RNC header buffer. And I'll just show you what that looks like in the source code, because I do have it here. All that's declared. There it is there. AMG RNC header buffer. And I'm just saying create, I'm just declaring 20 words. So that's 40 bytes effectively. Just as a buffer to actually read the header of the file. So when we do that, I'm just going to set that into A0. And on this side here, this is where the buffer is pointing to. So we should see the header of the file actually come into here. And we need correct registers. This is the size. So we're reading D3 is 16 bytes. So yeah, that's how many bytes we're going to read. And now we're going to call the read function. So I'll just show you where we are. We are here. And what we're going to do, just call read. And notice what's came back. It's came back in D0 is the number of bytes read, and it's sure enough it's saying that it's 10. And we make sure it hasn't returned an error, which will be a minus or the negative flag set. And then what we do is we're comparing what the number of bytes that we wanted to read with the number of bytes that we actually read. So we're comparing D0 with D3. That's fine. They were exactly the same. And then what we're doing is we're saying, right, get a pointer to the buffer where the 16 bytes that we just read, which we're looking at here. This is where that buffer is. And as you can see, we've now got in this small 40 byte buffer, although we didn't need 40 bytes, we've got the start of the file. So what we're going to do is we're just going to check the RNC part of it. So let's dereference A0 into D0. And as you can see, D0 now has RNC 01. Now, we're not really too bothered about the 01. So what we're going to do is we're just going to shift right 1 byte and get rid of that 01 by shifting 8 bits to the right. And there you go. And now what we're going to do is we're going to compare the value of RNC in D0, make sure that that is what it is, and it is, because it hasn't jumped into an error. And now that that's okay, we're now ready to read this value here, which is the unpacked file size. And what that's saying is if A0 is pointing to C36CE2, which is here, we're going to read from here 4 bytes dereferenced. So it's going to read into D0 the unpacked size of D133C. And there you go. It has read that into there. And then we're going to save that across into D6. We're going to move D5 into D1, which is the type of memory that we saved off. Can you remember when we said we didn't actually need the memory type yet? Now we actually do need that, so we're gonna need it. So let me have a look and see whereabouts we are. Okay, and as you can see, we've just passed this RNC bit here, and we're about to come down into the allocation of RAM. It's going to allocate that memory. So we're getting the exec base, because remember alloc mem is part of exec, so we're getting that into A6. and we're calling LVO allocmem with the value of D13C, and sure enough it has given us back a reference in memory to say this is where your block of memory starts. Okay, so let's just take a look at that. So 41BDO is what the operating system has given us back as a memory segment. So now what we're going to need to do is seek back into the file to the start of it and then read the contents of the whole file into there. So that will be the packed file. We're going to read the entire packed file into there. So was there an error? No, there wasn't. Save the pointer to memory. And that is the handle of the file. So remember, we haven't done anything with the handle of the file yet. We haven't closed it, so it's still available. The file is still open for use. So that, if you recall, that was saved into D4. So we're just putting that back into D1. And just take a look at this. And that is what is happening here. So we're setting up seek. So we're saying, right, okay, we need to get the go to the offset, the beginning of the file from 0, and we're going to seek back to the start of the file. I keep clicking on that and I shouldn't do. So that is the 0 to D2, and that is the, okay, and now this is the seek being ran, so it's seeked back. And now we're at the point of reading the entire contents of the packed file. So just keep an eye on what this looks like here. So what we're going to do is looks like we're setting up the file handle. So the file handle, which is still have open, we're going to move back into D1 because that's where it's needed. We're going to move the buffer, which is the address where our memory has been allocated, into D2, which is here. As you can see, 14BDO is in D2. And we're going to set D3, which means to 6Fs, which means read the entire file. And then we're going to cause it to read. And there you go, you will see that it has read the whole file into RAM, in our memory segment. So as you can see, it's got RNC, and we've got a lot of other data down the bottom here. It's read the whole lot. And yes, the file was read fine. And now what we're going to do is we're just going to close the file. As you can see here. So it needs the handle back of what we had into D1. And we're just going to close that. Now what it's going to do is it's going to unpack the file. Now it's just going to use that move multiple instruction again, just to save the values of A0 and A1, because A0 and A1 are going to get changed. We typically don't need to do that, but we're just going to do it for good practice. So what we'll find is that, just save that. Now what we're doing here is, because D5 has the memory segment that we allocated and the loaded packed file, which is at 14BDO, we need to tell the unpacker that that is where it needs to unpack from and unpack to. So it's going to unpack in place. So we set A0 and A1 to exactly the same place. A0 and A1 is in the same place there. And we just make a call to unpack. And what we should see is the memory contents have changed, and sure enough they have. And what you have there now is a IFF file. We have an IFF file because typically one will look like, if you ever opened one up, you'll see it starts with form and there's lots of zeros in there, and that's a bitmap header. We have a color map, that's what the C map is, and a bit further down we'll probably have a body. Yep, and then that is the bitmap data that is here. Now, just to finish this off, what we do is we're going to copy the A0 and A1 registers back to what they were, and we're going to copy the number of bytes, which we typically don't need to do, but we're just going to do it for reference anyway, back to the calling function. So we're just going to move D6 to D0, it was that anyway, and then we're going to reset back our registers, and then we're back into our main function. And we can see, was there an error? No, there wasn't, because we read our packed file. And it's going to set that anyway, but that's it, terminated. That's it, finished. And that is it. Okay. So, a couple of really useful resource to look into this is the Amiga developer docs, which has all of the information required to look at things like the open function call, the alloc mem, and free mem, and read and seek and close, and all of that type of stuff. All of those are actually documented in here, and the includes an auto docs, and you can search for them, and it gives you all the bits of information you need, what registers to set to where. I really suggest you have a look at them. That is the web address there. Go and have a look and see how everything's hung together. It explains things really well. But if that isn't enough, you can always welcome at AmigaGameDev.com, or here's the Facebook page, Facebook for Amiga Game Dev, or there's the Discord channel. I'm generally always around there, or around one of those. Give me a shout if you need help with anything. I'm always here to help, and always happy to help people out with the series. In the next episode, already got planned, we're going to be taking that IFF file, and we're going to be doing some things to it, which is reading the header of the IFF file, and then hopefully actually displaying it on the Amiga. So that's what's coming up in the next episode, maybe 2 episodes, depending on what feedback I get. And yeah, everybody, happy coding, and I hope you enjoyed the episode. I hope it hasn't been too taxing. This stuff's quite difficult to actually get over in a non-technical manner. It's very, very technical, but hopefully you've been able to follow along. If you get stuck, you know where I am, and thanks very much for watching. If you like the video, I'd really appreciate you subscribing and just clicking the like button on the video. Thanks very much.